Welcome to Reality Creative Video Alchemy. Today I want to talk about parts per million and concentration. I got a question from one of my associates. He said he went on a trip and he forgot to take my zinc solution, which I rated 20 parts per million, with him on his trip. So he had to buy, he wasn't feeling well, he had to buy colloidals, and he bought a 10 parts per million solution, and he tried it and it didn't work, and he wanted to know why did my stuff work and this other stuff not work. And well, there's a lot of factors that can go into that, especially from people that, manufacturers that, stamp this stuff out really fast. It could be quality control. It could be they're not measuring it properly, or they measured it so long ago that they're not measuring it now. I mean, as you know, I measure all my colloidals in the video in the laser microscope, so I know exactly what it looks like, the concentration that I have. So parts per million does not always equal concentration, and this can be a little confusing, because you get the standard parts per million formula, which I'll show you here. Basically, you take the material in grams that you've used, then you divide that into the amount of milliliters of fluid that you're putting it in. So let's say you use 5 grams of material, you use 500 milliliters of fluid. You should have, using this formula, a 10 parts per million solution of colloidal. Should is the operative word here. Like with low voltage electrolysis, there's waste. You'll get a black sludge on the electrodes that you got to wipe off. Now that doesn't go into the solution. So if you've only got 10 parts per million in the solution, you've done the math part of it. That sludge needs to be subtracted, which is absolutely impossible to do because you don't know how much that sludge weighs. You don't know how much sludge is on there. And these are things that manufacturers don't take into account. They just give you they use the general formula and they say, okay, you got a 10 parts per million solution, blah, blah, blah. But that's not concentration. When I started using the video microscope, I realized that this general purpose parts per million formula really shouldn't apply to colloidals. We really should have a new kind of measurement. And that's all well and good, but I was afraid we were going to just confuse the hell out of everybody with this kind of talking about parts per million here and parts per million there. And so I left it simply. And I based all of my formulas of concentration on basically what it looks like at various material. And how you cook a colloidal matters. I mean, do you cook it just with distilled water? Do you add an accelerant like sodium citrate? These are going to change the amount of colloidals that you're going to get on the output. So, 2 milligrams of material in using distilled water will not, and colloidals out will not be the same as 2 milligrams of material in using sodium citrate or citric acid, as an accelerant. You might have more or less colloidals depending on the colloidal, the condition, how well the accelerant goes along with whatever it is you're trying to cook. No, there's no oxidation with plasma arc, and there's no black stuff gets on the with anyway, doesn't get on any of the plasma arc stuff. You get no black stuff on there, so you have a pretty pure colloidal. And this is where when I started to see these plasma arc colloidals and compare them with the low voltage electrolysis colloidals, and the little bit of material that I use, I did it with the plasma arc. All right, I like to make with the plasma arc. It goes fast. This cooked in 1 minute, believe it or not, and used less than 2 milligrams of material to give me what looks like a 2 parts per million solution, according to the math. But in the video microscope, this is clearly a highly concentrated colloidal solution. And so parts per million may, when you see parts per million on a bottle, it may indicate the material used, but it may not necessarily indicate the concentration of the colloidal and how it's made and how you get it. I don't know if there's an easy answer for this because there's no industry standard. There's no way of measuring concentration that I could say, okay, this is a 2 milligram solution that is at 20 or 25 parts per million concentration. And of course, the math does not work out when you're using the formula like that, but at least you have some idea of what I'm talking about with concentrations, especially with my colloidal. When you're making your own colloidals, you have to also take this into account. I got a note from one guy. He said, sometimes I take a colloidal and it's great, and I feel the effects right away, and other times I take a colloidal and I don't feel the effects. Well, the reasoning on that, I don't know the exact specifics in his particular thing, but is he doing 2 different dosages of colloidals? Not everyone is lucky like me that I have the equipment that I can actually see the colloidals and measure them. The point is that, your concentrations on your various batches of colloidals may be completely different. The other thing could be your body, absorption ratios can change. Your body could need more colloidals on a particular day. Just because you're taking 1 teaspoon of colloidals or 1 tablespoon per day doesn't mean that tomorrow you're not going to need more. It's like my body needs more that day. You have to listen to your body. Your body says you're not having enough. You probably burned up the colloidals that were in your body. The storage of the colloidals is within the water in your body. It all flushes out in 48 hours, as you know, but you do have that liquid storage going on in your body. That could be getting low. And so, even though you're taking your tablespoon, you burned a lot of it up because your body needed it for some reason and took it. So with your colloidals, you're going to have to listen to your body of how much you want to take at any given time. I hope you've learned a little bit more about colloidals and concentration and taking it in the body and, your end result and product like that. I will talk to you again soon.